subtract fractions, we need a what? We need a least common denominator in order to form a common denominator. So what are we going to multiply this 1 over a squared by? Yeah, exactly. And what are we going to multiply this one by? Over a squared. And then down here, this one's going to be over a, and this one's going to be b over b. So we end up with a squared minus b squared all over a squared b squared all over a minus b over what? ab. We're dividing by a fraction, so we should multiply by the... So this is a squared minus b squared all over a squared b squared times ab over a minus b. Are we done? No, there's a bunch of canceling we can now do. Oh, we can also factor. What can we factor?
Difference of squares.
Top left, exactly. That turns into
A plus b times
a minus b. And then we could just tack on the ab, right? And what's the denominator? A squared b squared times a minus b. What cancels?
A minus b.
It does. So the a minus b's cancel. We're still not done yet, though, are we?
Yeah, you can take out the ab.
So that goes away, turning that into just a. That goes away, turning it into just b. So what's your final answer going to be? A plus b over ab. Yes. I missed something?
Yeah,
Cool.
I just got minus b.
Okay. And by the way, you see how I worked across here on this? You have an infinite amount of space effectively going to the right. I had students who, instead of scrolling down, would scroll to the right. Like they do one question down, they'd move over, do the next question down, move over. It made it so it was impossible to print, but like I'm not printing this stuff out. Another one. Who has a good one that they think we should do? Who has a same first step, right?
Yeah.
So what do we multiply the y by?
3 over 2.
So what does the top become? 3y minus y minus 3 all over.
3.
Oh, what do we have to multiply? Oh, over 3, yep. And then what do we multiply this 4/9 by?
3 over 9. 3y. 3y over 3y.
Do we have to multiply by 3? I think we can just do y over y.
Yeah, y over y.
Because you can multiply this one by
Oh, okay. Yeah.
3 over 3. So you end up with the same thing.
Yeah.
So what does it become on the bottom? 4y plus 6 over
9y.
Exactly. Now we're at the same place we were before. We're dividing by a fraction. So what does this equal? 3y minus y plus 3 over 3. Because what did I do with this minus sign? Distribute it. Times 9y over
4y
plus 6. So now we just have to be careful about simplifying and crossing things out. What's the first thing easy we could cancel out right now?
You could
3 and the 9, what does that become?
3y.
3. So let's just do that, and then this turns into what?
2 and 2.
Yes, the y is still there. I haven't canceled it. This turns into 2y. So what do you have here? 2y plus 3 times what? 3y all over what?
4y plus 6.
What can we factor out of the bottom?
Plus 2.
A 2. So you have 2y plus 3 times
3y.
all over 2 times 2y plus 3. What cancels?
2y plus
So what are you left with? You end up with 3y all over 2.
Mr. Seamon,
Yes.
I'm confused as like,
Or the day before, or whatever. I think was it yesterday?
No.
Okay, so this is an equation. What's the first step?
Multiply by 6x.
Find the what?
These terms.
And then multiply by the...
Oh, yeah,
So what is the LCD? What is the LCD? 6x. We did these on the board, 6x. So what do you do with the LCD?
Multiply.
Everything by the LCD. So it's 6x times 1 over 3x plus 6x times 1 over 2x equals 6x times... Why are we allowed to do that? Well, if you multiply everything by the same thing, it doesn't change the overall value of the answer.
Just cancel out.
So now what do we do? Now what do we do? Yes.
Well, actually, I think for this one, you were just supposed to find what x couldn't equal.
Oh, okay. So let's take it one further. Let's just solve this one, okay? But you're absolutely right. So if we wanted to find out what cancels here? A lot of things. What does the first one become? 2. 2. The x's cancel. The 6 cancels, leaving you with 2. What does the next one become? Plus 3. And then what happens here? What's the only thing that cancels here? That cancels. You get 2 what?
X.
No, you don't. 2x squared is what you get. Do any of the x's cancel?
Oh, yeah.
No, there's 2 x's in there. X times x is what? So you end up with 5 is equal to 2x squared. What do I divide both sides by? 2. So x squared is equal to what? No. 5 over 2. What do I do to both sides? We have a square, so what do I do to both sides? Yeah, take the square root. So what does x equal?
Square root of 5 over 2.
Yeah, what do you put on the outside?
I
What do you put on the out? Not done yet. What do we put on the outside of this? What's the square root of 4? And what's the square root? So what do we put on the outside of this? Plus or minus. There you go. Nice. What's that first step? Give me a verb. Find the least common denominator. Can someone tell me what the LCD is? What's the LCD going to be? Yeah.
2x minus 7 times x minus 4.
Yes. A common denominator is always just the product of the two. So what do we multiply both sides by? That. We multiply both sides by that. So if we do both sides by that, I'll actually just copy it here. Let's do that here. We take this. We put it here. And we put it here. And then we have 3x plus 1 over x minus 4 equals 6x plus 5 over 2x minus 7. Hey, what cancels on the left-hand side?
X minus 4.
What cancels on the right?
2x minus 7.
So what are you left with? 2x minus 7 times
3x plus 1.
equals
6x plus 5
times.
x minus 4.
At this point, what do you have to do? You have to distribute. So you end up with 6x squared plus 2x minus how many x? 21x minus 7 equals 6x squared minus 24x plus 5x minus 20. Take a look at that terms.
Like terms.
So what do you get here?
19,
Negative 19x minus 7, right?
Yeah.
Equals what?
Negative 19x minus what?
20. What cancels on both sides?
19.
Negative 19x. So what are you left with?
Negative 7 equals negative 20.
Negative 7 equals negative 20. And you're like, meh. What does that mean? Assuming that all of your algebra is correct, what does that mean?
It's not that.
What are the solutions?
Nothing.
No solutions.
Whoa.
That's cool. That happens. That can definitely happen. That can definitely happen. Assuming our algebra is correct. So for me, on this question, I would then go back and check my algebra to see if I did it correctly. Let's see here. Did I copy it down right? Looks like it. Did I multiply 2x minus 7, 3x plus 1, 6x plus 5, x minus 4? Did I distribute correctly? 6x squared, 2x minus 21. Looks like it. So, assuming all the algebra is correct, what's the answer? No solutions. Same amount of work. You had to show that there are no solutions. Kind of cool. So here we go. How many variables do you see? 3. So let's say I just told you p was equal to 10 and q was equal to 20. How do you go about solving for f? What do you do first? If I plug them in, yeah. So you have 1 over f is equal to 1 over 10 plus 1 over 20. In order to add fractions, what do you need to do?
Multiply 1 over 10 by 2.
You need to multiply this one by 2 over 2 to get a. So 1 over f is equal to 2 over 20 plus 1 over 20. But what's 2 over 20 plus 1 over 20? 3 over 20. So if 1 over f is equal to 3 over 20, what could you do next, Mike? Sorry, David, you came up with this.
Cross multiply?
Yeah, cross multiply is the same thing by if you have a fraction equaling a fraction, cross multiplying is the same thing as multiplying by the LCD. So in this case, if you cross multiply, what do you get when you cross multiply? Cross multiply, you end up with 3f equals 20. So what does f equal? Can you get the door, please, somebody?
I got it.
No, you got it? Cool. 20 over 3. Excellent. So that's if you have specific numbers to plug in. That's kind of the process. That is the process. One of the orders. Are there different orders for simplifying? Sure. You could do it instead of cross multiplying. You could multiply by the LCD.
So that's what we have to do.
Yeah, in that case. So let's say instead I just said, okay, we're going to leave p as it is and leave q as it is, but we want to solve for f. So what's going to be in our answer if we're going to solve for f without plugging in 10 and 20?
Get a common denominator.
No, I'm not asking you what to do. What's going to be in our answer? Yes? P and Q, exactly. P and Q will still be there. So we need to do a similar thing. So how do we add fractions? What do we multiply this one by? Yes. What do we multiply this one by? Q over Q. And that's a terrible Q. It's not the best. So what do you have? 1 over F is equal to Q plus P over what's the common denominator? I do not know why mathematicians like to pick letters that are similar in shape. Do we have a fraction equaling a fraction? What can we do now if we have a fraction equaling a fraction? Could cross multiply. That's the same thing as multiplying by the LCD. So what do we end up with if we cross multiply?
QP.
QP, because that's this one, right?
Yeah.
Equals
F times
Q plus P. If we want to isolate F, what do we divide both sides by now?
Q plus P.
Q plus P. So we get F is equal to QP over.
Q plus P.
This is really helpful because now whatever values you can come up with for Q and P, you can just plug it in here. So what were our initial values before? P equals 10 and Q equals 20. If we take these now and plug them in, what do we get? We end up with 200 over what?
30.
What do we end up with? 200 over 30, which is 20. Yeah, I wrote the answer and. What do you end up with?
60s? Oh.
Let's cross the zeros out.
Oh,
Should we end up with the same thing? Yes, but this is super helpful because I could say, well, if Q is 5 and P is 7, what is it? You can just plug it in here as opposed to doing it. This is super helpful. So for example, if I have a formula that takes Celsius and puts it into Fahrenheit, maybe you want to do the reverse. Instead of doing it each way, you can solve for the other variable. So isolating a variable is super helpful. Does the math change? No, the math does not change. So let's say I gave you this one right here. Do this one for me. Solve that for n. This one's a little harder. Solve that for n. See if you can solve it for n. Let's highlight n here. So what's our goal if we're trying to isolate n? How many n's are in there?
2.
So if we're going to isolate n, we need to combine them somehow. So what should I do next? One word. What should I do next? Nope. Distribute. That was a great guess. Divide. Let's distribute. Where's the one place to distribute, Hannah? Yeah, so what does it become on the left?
IR plus IN.
IR plus INR is equal to NE. But how many N's do we have here?
2.
So we need to combine them in order to make this go in the direction we want to go in. We've done something like this before. We need to put everything with N's in it on one side and everything else on the other side. So what should I do right now, Chris? What would you do now?
Divide by E.
No dividing, no dividing, no dividing.
Oh,
No dividing. You have to get them on the same side first. Yes?
Subtract I and R.
Sure. So you get I keep on having the highlighter keeps coming up. So what do you have left?
So
IR
equals
NE
minus I and R.
minus INR. Okay, so we have n's all on the same side. Everybody sees that right here? Is everybody with me so far? Do you understand the algebra I've done so far?
Are the types of R's?
What'd you say? Factor, factor, factor. Which side do I factor?
The one with the M's in it.
Exactly. What do I factor out?
Yeah.
The n. So I have IR is equal to n times
E minus
e minus
IR.
I lowercase r. Now what do I divide by?
E minus.
E minus IR.
So what do I have? IR divided by
E minus
e minus lowercase r equals what? N. Have we isolated n?
Yes.
We have isolated n. The key thing to realize is that in our original equation, how many n's were there? 2. So if we're going to isolate n, we have to have how many n's?
1.
One of them. One of them. Your first goal when you're trying to isolate something that there are multiple things of is going to be get all the things with that thing on one side and everything else on the other. And then what do you do? What's that word? Factor. Factor, 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 factor. Because you go from here, what do you do from here to here? Factor. You took the n's and they went right there. Now what do you divide by? If you divide by e right here, does that really help you? You've isolated that n, but what about this one?
Yeah.
It makes it worse. So you have to wait to divide until after you have factored. So now what I'd like you to do is get up to the board, sideboards, and you and a partner, I want you to work on this question right here. You read the question, you understand it, and then you write down, what are you trying to find out? You're trying to find out number of people without what?
Insurance.
Insurance. And then you have to give that a variable name. Let's say P or N or X, whatever you want to call it. And you know that the ratio of people without insurance is this. So the ratio has to stay the same when the population is 302. The population right now is like 306 or 7. I think it's a little old, right? So what do? What's that called? So you end up with 15p is equal to 100, not 15p, what am I doing? 100p is equal to 15 times 302. I like people doing that, million, that's fine. And when you do this out, you end up with p is equal to 45.3 million. Excellent. That was very good. Here you go, another one. It's another, you did this, you said, what do I need to find? G is the additional, what?
Gas needed.
Additional gallons of gas. So you know it's 10 over what? 210. It's going to be equal to G, yep, over. Yeah, and you end up with G is equal to 25 point what? Like 47 if you round it to 5, yeah, about 47. Excellent.